Okay, for our next presentation, we had Mohamed Taddist going to be speaking, but he's unfortunately not here. We have a video of his presentation, and Hans is going to go ahead and introduce for us.
Thank you. Thank you. So hello, colleagues. We had a very, very talented master student from the EPFL in Lausanne working at the EBU for some time, and he has delivered a great paper which was accepted. And unfortunately, we could not bring him over for some reasons, but he was so kind enough for us to record the presentation. So please have a look what he is presenting to. It's really valuable work, extremely valuable work, I would say, because it deals with a matter which is really on our heart at public service media operators, which is trust, newsrooms, and how we can actually enhance trusted audiences. So with this, I think we kick off. Let the presentation run, and then I'm here and try to answer some questions. Or if I can't answer them, I will pass them on to Badr. Here we go.
Hello and welcome to this session on privacy vulnerabilities in C2PA content provenance systems with focus on news media and broadcasting workflows. My name is Mohamed Badr Taddist, a researcher from EPFL Switzerland and EBU associate. So without further ado, let's step into the presentation. So what is C2PA? C2PA stands for the Content Coalition for Provenance and Authenticity. It provides a set of technical documents, guidelines, and recommendations. C2PA is also a framework that seeks to establish trust between content creators and their consumers through the content credential specifications. It is also important to note that C2PA does not provide value judgment about the truthfulness of media it signs, but rather verifies its provenance. C2PA provides provenance and verification to safeguard brand reputation by ensuring published assets come from trusted origins and offers a clear audit trail, deterring tampering when it matters most. It also builds audience trust and slows misinformation by making creation and edit histories transparent. For fact checkers, it gives them fast, effective tooling through signed manifests and edit trails, so verification takes seconds rather than hours. It also helps editors to efficiently validate sources of content. Together, these practices protect the brand, strengthen trust, and streamline newsroom workflow. So how does C2PA work? C2PA attaches signed manifest to each asset so anyone can verify what it is, who touched it, and whether it was altered, by ensuring the following strong security properties. First, integrity of manifests. Each claim in the manifest is protected by cryptographic hashes with salts and digital signatures, so any change to the content or metadata is detectable. Second, it offers authenticity and non-repudiation of signers who use certificates to prove who they are, and they apply signatures so actions are attributable and can't be credibly denied later. Last but not least, C2PA ensures the availability of manifest by relying on trusted timestamp tokens to record when the manifest existed, and a soft binding mechanism that keeps the manifest discoverable with the asset, even if it has been removed, copied, or re-encoded. We formalize news publishing and broadcasting workflows as the following. A photojournalist captures the source media asset on camera and hands it off to visual editor. The editor applies necessary adjustment, producing an edited media asset, which is then moved to the news editor in the media asset management system. And the news editor reviews, applies newsroom policies, and stamps the content. From that, the asset exits the newsroom with its provenance and gets published to the web. To enable C2PA for this simple workflow, we start at the camera, which captures the photo or video and attaches a source manifest with cryptographic hashes and a device signature. The asset moves into a software editing tool, where the tool imports and preserves that C2PA manifest, records edits as a new claim, and outputs an edited media asset with an updated provenance chain. Next, the publisher's stamping tool verifies the chain, applies the organization's certificate and trusted timestamp, enforces any reductions, and soft binds the manifest so it stays discoverable. Finally, the media gets published to the readers and platforms and can now verify who created it, what changed, and that nothing was tampered with. In the next slides, I'll show the components and parties that create and verify content credentials in this workflow. Starting with claim generators, which are hardware or software like cameras, editing tools, and identity stamping tools that can access the media and its metadata. In C2PA, they must validate any incoming manifest and record all changes such as edits, metadata additions, or reductions in a new signed manifest that extends the media's existing provenance. Next, certificate authorities play an important role in the C2PA ecosystem. They issue and manage certificates for claim generators and organizations, publish revocation data, and answer status checks via well-established PKI protocols, so verifiers know whether a certificate is still valid or not. Next, we have trusted timestamp authorities that issue cryptographically signed timestamp tokens for manifest signatures. These tokens prove when the manifest existed, preventing back or forward dating and strengthening long-term verifiability of C2PA content. Lastly, manifest repositories are network services that hold the C2PA manifest for media. They store C2PA manifests and make them retrievable by links, unique identifiers, or soft binding values. These repositories could be third-party owned or managed by the content publishers within their infrastructure. They play an important role in decoupling C2PA provenance from their media assets by hosting manifests separately and linking via soft binding. For example, a publisher can ship lighter files and streams, cutting bandwidth and latency while still letting C2PA verifiers fetch full provenance on demand and asynchronously. Finally, claim verifiers are websites or app components that check content credentials and display provenance information to users. As we have seen previously, claim generators also act as verifiers because they must validate any content they ingest in the workflow chain. If the content credentials are not embedded or was stripped, the verifier fetches the manifest from a manifest repository. Then it checks the signer's certificate status with the certificate authority, validates the trusted timestamp with the timestamp authority, verifies the C2PA hashes and signatures, and confirms the signer against an approved list of trusted signers. It then shows the user a clear validity result as trusted, valid but interested signer, or invalid or tampered with content. The complete overview diagram reduces to two phases. On the left is the provenance generation where the publisher's workflow applies C2PA, and on the right is verification where client verifiers check the published content credentials. Certificate authorities, timestamp authorities, and manifest repositories are present in both phases. Now that we've seen how C2PA runs end-to-end, notice what else it introduces: new data, new identifiers, and new network lookups. Those are great for trust, but they also create places where people can be linked, profiled, or tracked. 3 hotspots to keep in mind as we move to the next slides. First, capture and editing where devices, certificates, and rich manifests can link a journalist as contacts, leaving what was meant to be hidden. Secondly, during publishing phase, when manifests are decoupled and stored in repositories, their links and references can reveal relationships between assets. And through the verification phase, fetching manifests, checking certificate status, and validating timestamps all call home exposing IP, time, and location of users. Next, I'll only walk through some of these privacy vulnerabilities, what they look like in the simplified publisher workflow, the concrete mitigations newsrooms can adopt, and the trade-offs and price in terms of privacy journalists and consumers might need to pay in some cases for C2PA authentic provenance. For the sake of time, I'll only cover a subset of these vulnerabilities. Please refer to this empty paper for more details. Our research scope included the point of capture, which acts as the start of the provenance chain at the source. We explored the linkability issue that affects some of the cameras implementing C2PA. C2PA-enabled cameras are special type of claim generators that create and secure the record of a media's origin. They use built-in C2PA firmware and cryptographic chips to sign metadata in real time. The content credentials are attached by the camera with the media and travel along with them. Crucially, camera-generated content credentials can prove that a specific camera captured a photo at a given time and optionally include location. Including date and location depends on the implementation and is usually opt-in. Our research covered Leica and Sony's C2PA implementation, but in this presentation we only evaluate Leica's approach to content credentials. To learn more about Sony's findings, please refer to our SMT technical paper. So why C2PA is so useful at capture time? For photographers, it can prove that their work is authentic and not AI generated. For agencies, it helps them gain extra guarantees that assets come from recognized photographers and they can trust but verify the source using the camera's content credentials. And for the public, they can inspect the image's history, review edits, and distinguish real from synthetic media. But what if the same C2PA-enabled camera is used in two contexts, safe versus unsafe content that might put the life of the photojournalist at risk? Broadcasters, publishers, and photo agencies are usually the ones that make the decision of when they can openly credit the work of a photographer versus work where the publisher takes attribution to keep the reporter safe. Publishing Leica C2PA sensitive photos, even without naming the photographer, is risky, as device-bound certificates in content credentials can still link those images back to the photographer, exposing their identity. This problem is due to the fine granularity of device-bound certificates of the cameras. In fact, the very feature that guarantees authenticity and security by providing unique certificates for every single camera creates a significant privacy risk. An attacker could de-anonymize a photojournalist by matching the camera's certificates in the content credentials of an unattributed yet authentic image from an agency to those of licensed images published under the photographer's name. To solve this problem, publishers and agencies should consider the following solutions. First of all, a coarser camera certificates to provide a bigger anonymity set. This could be implemented by providing a model-level certificate for every unit of the same camera model. It should share one certificate. The trade-off with this approach is that if one key is compromised, all units of the camera model are affected. Or go for an organization-level certificate so that all newsroom cameras use the publisher's agency's certificate like Sony's approach. The approach suffers from the same security risk as described before, however. Per-shot key rotation is also an approach where the camera rotates keys, so each photo is signed with a different certificate approaching unlinkability. This approach is more complex in terms of implementation and requires advanced key management, handling, and improved camera hardware. Another solution angle is through policy controls by distinguishing sensitive use versus standard use camera. The trade-off with this approach is that journalists might not always know in advance which assignment is safe, as content flagging is performed post-capture. And finally, make use of zero-knowledge proofs to show that this image was captured by a genuine camera without revealing device details. The trade-off with zero-knowledge proof is that they are computationally heavy and difficult to implement on constrained camera hardware. Google Pixel 10 took the approach of per-shot key rotation, as Pixel 10 implements the latest version of C2PA version 2.2 and is conformant with respect to the C2PA conformance program, achieving assurance level 2 for the C2PA claims it generates. In Google's implementation, no two images share the same certificate in their content credentials, and their implementation rely on Android key attestation and Android Strongbox to auto-generate one certificate for each captured photo. And with that, we move on into the next privacy vulnerability that we discovered that involves the confidentiality of source content. Sensitive content requires careful handling in any publishing workflow, and failing to redact sensitive content such as blurring witnesses' faces or distorting voices can cause harms to people. Consider this image which was captured with the C2PA-enabled camera. We then blur the face of the person with the C2PA software editing tool. Since the content credentials of the edited and blurred image include a thumbnail of the camera-captured image, we can recover the face of the person from the manifest of the C2PA camera, which was a Leica. More generally, as content credentials gain adoption, publishers and broadcasters must protect source privacy and audit provenance data for leaks before publication. They should not just vet the content, but verify the attached manifest does not expose any sensitive details. In this example, the embedded thumbnail compromises the source confidentiality. Anyone can see it by running the asset through the official C2PA verifier. Editing tools should let editors remove the thumbnail assertion from the manifest, and the cameras should offer photographers the option to omit thumbnails in the source manifest from the start. Another defense is to remove the camera's manifest before publishing to protect the source privacy, but this weakens authenticity since user can no longer verify where the content came from. Another approach is to use zero-knowledge proofs, which can prove that an editor performed a specific action, for example blurring, on a private C2PA signed camera image without revealing the camera's manifest or the original image. The trade-offs is that zero-knowledge proofs are computationally expensive and currently only limited to certain edits and media types, which especially is high cost for video and high-resolution imagery. Our final thoughts and recommendations are that privacy-sensitive workflows should evaluate C2PA before it directly integrates it, especially at the source. We also encourage broadcasters and technology vendors implementing C2PA to move from version 1.4 to version 2.2 and commit to C2PA's conformance program to align with the rest of the C2PA ecosystem and address known security gaps in version 1.4. Next, we plan to extend our research to the creator assertions working group focusing on how identity is expressed in C2PA version 2.2. Thank you. Please feel free to get in touch and read the SMT technical paper. Bye-bye.
Thank you. And thank you for filling in on this, Hans. Greatly appreciate it. And do we have any questions from the audience or anybody who wants to put some in on their QR code?
So I'm not as beautiful as Badr, but still you can ask a question if there is a question. I hope you appreciate that we're in early stages of the C2PA implementations. Badr has done a fantastic work in doing a first analysis, also showing what the current devices can do on the market. We from the EBU look further, as he indicated in his research. We look further into the implementation of C2PA, in particular newsroom workflows, which is predominantly where we see the applications. And stay tuned, I would say, also for the next publication from Badr. He's on it.
Okay, thank you very much for that, Hans. Greatly appreciate it.